Hello and welcome to another Hulk software tutorial. This time we will be going over another automatic bone material property application software for assigning material data to ABAQUS input files. This is a good option if you don't have access to materialized mimic software but still want to use CT-derived material property data for your finite element evaluations. For simplicity, we've made this software easy to download via pip. First, I'm going to make a new Python environment for demonstration. After initializing our environment with Python, we can use the pip install py_bmd_abacus or pip install py_bmd_abacus to install the software package. After installing py_bmd_abacus, we just need to create an orphan mesh using ABAQUS CAE. This can be done by first importing a part, then creating an instance in an assembly, and then meshing your part. For demonstration purposes, I've used a fairly refined mesh, and a sampling ghost ring in the same coordinate system as my CT humerus. Next, you just need to create an ABAQUS job and write the input file. There's no need to actually run your job at this stage. Moving forward, we can actually begin to use our BMD assigning tool. First, ensure that you are using the correct Python environment. Next, import our py_bmd_abacus library. In this particular case, you can either import all public functions, or you can just import the main tool, which is the extract element data tool. This tool has a number of required inputs and a few optional ones too. Your INP file will be the orphan mesh that we just created. Please note that at the time of this video, we have not yet added in set or surface functionality, and this tool will only assign material properties to a single meshed part. You will also need to identify your DICOM directory where your CT data is stored. For the output scale, you can use HU, density, or modulus, but modulus is the only one which will output a .inp file. The other two just return your element data as a NumPy array. Next, you need to indicate the phantom values for the Hounsfield unit density calibration. We've created docstrings for most of the functions here, so it should be fairly straightforward for you to learn the arguments necessary to use this tool. You can explicitly set the number of materials as well as the Poisson ratio if you so wish, but those are set to 20 and 0.3 by default. After identifying your required arguments, you can run the program and even keep track of how long each function is taking. These have been accelerated using Numba, so depending on your computer, this could be fairly quick. However, for a massive mesh, something like a full humerus, this could take upwards of 5 minutes, so please be patient. If you want to test that it's working, you can always feed in a small mesh to start. After the program has generated an output mesh, you can now import your new INP file into ABAQUS for your analysis. As you can see here, the output has generated new materials, sections, and has assigned materials to those sections in your meshed part. That wraps up our introduction to using py_bmd_abacus. Please feel free to try out this tool for yourselves. It's not flashy and it only does what's required, so it should be a quick learning curve. As always, thank you for watching.